Superconductivity is a phenomenon in which a material can conduct electricity without any resistance, meaning that no energy is lost in the process. Superconductors have many potential applications, such as faster electronics, more efficient power transmission and levitating trains. However, most superconductors only work at very low temperatures, which limits their practical use. Recently, some scientists have reported achieving superconductivity at room temperature, which is a major breakthrough in the field. However, these experiments require extremely high pressures, which are difficult to maintain and measure. Therefore, the results are still controversial and need to be verified by independent studies. Here are some of the latest research papers on superconductivity at room temperature. 1. First room temperature superconductor excites and baffles scientists. This article describes how a team of researchers created a superconductor made of carbon, hydrogen and sulfur that works at temperatures up to 15 degrees Celsius, but only under pressures of about 2.6 million times that of Earth's atmosphere. 1. The team used diamond anvil cells to squeeze the material and laser light to induce chemical reactions. 1. The article also discusses the challenges and implications of this discovery. 2. The first room temperature superconductor has finally been found. This article summarizes the same study as above, but in a more accessible language for general readers. 2. It explains what superconductors are, how they work and why they are important. 2. It also highlights some of the limitations and uncertainties of the new material. 3. Room temperature superconductivity has been achieved for the first time. This article provides more details on the experimental methods and results of the study mentioned above. 3. It also compares the new material with other high-pressure, high-temperature superconductors that have been discovered in recent years, such as those based on hydrogen and lanthanum or hydrogen and sulfur. 4. Controversial superconductor may be a game-changer. This article reports on another study that claims to have found a superconductor that works at room temperature and relatively low pressure. 4. The material is made of hydrogen, lutetium and nitrogen, and changes color from blue to pink as the pressure increases. 4. However, this study has not been peer-reviewed yet and has faced criticism from other experts in the field. Achieving superconductivity at room temperature is a very challenging task that requires overcoming several obstacles. Some of the main challenges are: 1. Finding materials that can exhibit superconductivity at higher temperatures without losing their stability and structure. 1. Most superconductors only work at very low temperatures, which limits their practical use. 1. Some materials, such as hydrogen-based compounds, can achieve higher temperatures, but they require extremely high pressures, which are difficult to maintain and measure. 2. Understanding the underlying physics and mechanisms of superconductivity at room temperature. 2. There is no unified theory that can explain how different materials become superconductors at different conditions. 2. Some theories, such as the BCS theory, work well for conventional low-temperature superconductors, but fail to account for unconventional high-temperature superconductors. 2. Other theories, such as the Mott insulator theory, are still under development and need more experimental evidence. 3. Verifying and reproducing the results of room-temperature superconductivity experiments. 3. Due to the complexity and sensitivity of the experiments, it is hard to confirm and replicate the findings of room-temperature superconductivity. 3. Some studies have faced criticism and skepticism from other experts in the field, who question the validity and reliability of the methods and measurements. 3. Therefore, more independent studies are needed to verify and validate the results. What is magnetic levitation? Magnetic levitation is a phenomenon in which an object is suspended in the air with no support other than magnetic fields. The magnetic force is used to counteract the effects of gravity and any other forces that might cause the object to fall or move. Magnetic levitation can be achieved by using different types of magnets, such as permanent magnets, electromagnets, superconducting magnets, or induced currents in conductors. Magnetic levitation has many potential applications, such as 1. Maglev trains. These are trains that use magnetic levitation to move along a track at very high speeds, up to 600 km per hour or more. 1. They have many advantages over conventional trains, such as lower noise, less friction, less maintenance, and less energy consumption. 1. Maglev trains are already in operation in some countries, such as China, Japan, and South Korea. 2. Contactless melting. This is a process that uses magnetic levitation to melt and shape metals without touching them. 2. This can prevent contamination and oxidation of the metals, and also allow for more precise control of the temperature and shape. 2. Contactless melting can be used for making high-quality alloys, nanomaterials, and biomedical device. 3. Magnetic bearings. These are devices that use magnetic levitation to support rotating shafts or other moving parts without physical contact. 3. They can reduce friction, wear, and vibration, and also increase the speed and efficiency of the machines. 3. Magnetic bearings can be used for turbines, compressors, pumps, motors, and generators. 4. Product display. This is a technique that uses magnetic levitation to showcase products in a visually appealing way. 4. It can create a sense of wonder and curiosity among customers, and also highlight the features and benefits of the products. 4. Product display can be used for jewelry, watches, toys, gadgets, and other items. These are some of the examples of how magnetic levitation can help in various fields and industries. What is BCS theory? The BCS theory is a microscopic theory of superconductivity that was developed by John Bardeen, Leon Cooper, and John Schrieffer in 19571. The theory explains how certain materials can conduct electricity without any resistance when they are cooled below a critical temperature. The main idea of the BCS theory is that electrons near the Fermi surface, which are the most energetic and mobile electrons in a metal, can form pairs called Cooper pairs. These pairs are bound by an attractive force that is mediated by the vibrations of the crystal lattice, called phonons. The Cooper pairs act as bosons, which are particles that can occupy the same quantum state. Therefore, they can condense into a single quantum state, called the superconducting state, which has a lower energy than the normal state. The superconducting state is very stable and coherent, meaning that all the Cooper pairs move together as a single entity. When an electric voltage is applied to the material, all the Cooper pairs move in the same direction, creating a current. This current can flow indefinitely without any resistance. Thanks for watching this video. If you enjoyed watching this video, please like and subscribe to my channel.